Good afternoon, advanced algebra students. I hope you are doing awesome. I am super excited to be doing another Algebra 2 lesson with you. We are almost done with our notes for the quarter, so I know that's probably very good news for you to be hearing. We've gone through all of chapter 1 in our advanced algebra book. We've taken some detours into the Algebra 1 book, and we're almost all the way done now with chapter 2 of our advanced algebra book. So we are going to do section 2.5 today, completing the square. And this lesson basically teaches us another way that we can use to solve equations with x squared. So we have primarily looked at solving equations with x squared by using factoring. You know, set the equation equal to 0, factor, set the factors equal to 0. And to be honest with you, that's going to be what you do the majority of the time that you have an equation with an x squared in it. Sometimes you can just simply take the square root of both sides, and so if that's an option, you know, that is always great to do. This is a method that is somewhat similar to taking the square root, but involves a little bit of extra steps to kind of get the problem set up to be able to take the square root. So it's called completing the square, and basically we're going to review how it is that we do that. Now, in order to know how to complete the square, what we need to do is have this formula. So I would put this at the top of your notes. X squared plus bx plus, in parentheses, b over 2, n parentheses squared equals, in parentheses, x plus b over 2 squared. Now this looks super intimidating. It's not as bad as it looks. But basically what this formula is telling us is we can take a quadratic expression that's written using 3 terms, and we can write it as something squared, a binomial squared. Now, can you think for a minute why I would want to write it as something squared? Why would it be beneficial to me to rewrite a trinomial as a binomial squared? The reason why is because if I can rewrite it as something squared, then I can take the square root of each side to solve. So this is basically an extension of what we learned about last time. Now, let's go ahead and do example 1. Example 1, we have the trinomial x squared plus 8x plus 5 equals 0. And we are being asked to rewrite this as a binomial squared. So, in order to do this, what we need to do is make this term here be one that will allow us to rewrite it that way. Notice if this is in the form x squared plus bx, my b here would be 8. Then this term right here would need to be 8 divided by 2 squared, or 4 squared, which is 16. This is not 16, this is 5. So the method that we're going to use is we're going to get rid of whatever constant was there. So we're just going to write this as x squared plus 8x, leave a little bit of a gap, and set that equal to negative 5. So we're going to isolate x squared plus bx. Then what I like to encourage students to do is to add blanks to both sides. This is a visual reminder that we're going to be adding something to one side, because remember, with an equation, you can add whatever you want to one side as long as you add it to the other as well. Now, we just finished talking about how we wish this last term here was 16, because that would be b divided by 2 squared. So we are going to add 16 here and here. Now, we can easily simplify the right-hand side. 16 minus 5 is just 11. And then on this side right here, because I've put my equation in this format, I know I can rewrite it as x plus b over 2 squared. b is 8, 8 divided by 2 is 4. So I can rewrite this as x plus 4 squared equals 11. Now, normally we would continue on from here to solve, but this problem was just asking us to set up the problem correctly, and we have done that. Okay, I think I'm going to do one more like that just to give you a little bit more practice. So let's do example number 2. It's the same instruction where we want to set up the equation so it's in the format of a binomial squared equals a number. All right, so we've got x squared minus 6x minus 11 equals 0. Remember, our first step is to isolate x squared plus bx. So we are going to add 11 to both sides, and now I have x squared minus 6x, I've got a little space here, equals 11, and then I have a space there. Now, can you stop for a minute and see if you figure out what we need to add to both sides? The thing we need to add to both sides is b over 2 squared. b is negative 6. Negative 6 divided by 2 is 3. 3 squared is 9. So I am adding 9 to both sides here. The right-hand side just becomes 20. And now to rewrite x squared minus 6x plus 9, I follow the right-hand side of the formula, which means I write this as x plus b over 2 squared. b over 2 would be negative 3, so I'm just going to turn this into x minus 3 quantity squared. Okay, good. So we've kind of learned the proper way to set up the problem. Now what we're going to do is look at what you would do from there. Alrighty, so let's do another example, but this one we're going to go all the way to the end. And I'm going to continue to leave this formula on the board because I think it really is helpful to be able to use. Alright, so example number 3, we're going to solve by completing the square. So now we're going to take the problem all the way. X squared minus 2x plus 1. Actually, hold on. The original problem was x squared minus 2x plus 3 equals 0. So first we isolate x squared plus bx. We're going to subtract 3 from both sides. Now we need to figure out what do I need to add to both sides. I want to find my b, that's negative 2. b divided by 2 would be negative 1. Negative 1 squared is positive 1. So I'm adding 1 to both sides. The right-hand side becomes negative 2, and on the left, I have x minus 1 quantity squared. Now, the cool thing is, because we have our quadratic equation written now as a binomial squared, if I want to solve, I just take the square root of the right-hand side and the square root of the left. The square root cancels out my squared, so now I just have x minus 1 on the left. On the right, I have the square root of negative 2, which is the same thing as negative 1 times 2. Now remember our last lesson. The square root of negative 1 is I. So this is equivalent to saying that x minus 1 equals I times the square root of 2. The last thing that we would need to do, and you know what? Because I took a square root here, I do need to add a plus or minus. Don't forget that. Okay, so the last thing I need to do is add 1 to both sides. So I'm going to have x equals 1 plus or minus I radical 2. Okay, let's do one more example. Maybe 2. I'll have to see how this one goes. All right, let's have this be example number 4. The thing I found with solving by completing the square is that once you've done it several times, it does become much easier, but the first few times are usually fairly challenging. Okay, so we want to isolate x squared plus bx in this problem by subtracting 8 from both sides. Then we want to figure out what to add to both sides. So my b is 4, b divided by 2 would be 2, 2 squared is 4. I'm going to add 4 to both sides. The right-hand side becomes negative 4, and on the left I have x plus 2 quantity squared. I do want to take the square root of both sides. So on the left I have x plus 2, and on the right I have negative 1 times 2 times 2. The x plus 2 is good still. I take out a 2 and an I from the right, and then I need to subtract 2. And of course I need to make sure I have my plus and minus in here. So I'm going to have x equals negative 2 plus or minus 2i. All right, the next problem is fairly intense with fractions, and it's a word problem. We do have one very similar to that in the homework, so I think I'm just gonna wait until the homework to get to that, so I don't stress you out too much. So that is good, actually, for our 2.5 notes. I look forward to seeing you in Zoom. Bye, guys.